Let's look at the RMI concepts. RMI stands for Remote Method Invocation. This is nothing but a distributed application in Java. Now, the architecture of RMI goes like this. RMI is basically used for, let's say, I have a object residing in one machine, and that object has to be accessed from another machine to invoke the methods or the business methods of that particular object. And when I invoke the business methods of that object, it goes to the server or the machine on which the object is residing, executes the method, returns back the result to the caller. So, the architecture goes like this. On the client side, we have what is known as a stub, the RRL, and the transport layer. On the server side, we have the skeleton, the RRL, and the transport layer. The transport layer is responsible for keeping the connection between the client and the server. On the client, we have a stub. A stub is nothing but a proxy for the object. As we said, the object would be residing in one machine, that's called as a server. So, we have an object at the server, and you would like to invoke that object out here, the method on that object here. So, I need a representation of that remote object at the client place, and that's the stub. So, stub is the proxy for the remote object. Just like how you would have represented probably your friend in a classroom, that's how a stub represents a remote object out here at the client side. When a client makes a call on the remote object which is residing at the server, the call comes to the stub. The stub then passes that request to the RRL. RRL stands for Remote Reference Layer. RRL identifies the type of server, that is, whether it's unicast or multicast. RMI supports to unicast servers. That is, unicast means you cannot replicate the objects, whereas multicasting you can replicate the objects. In the RRL layer, there is an object that is available called as a remote ref. Remote ref. The stub, once it gets the method call, it invokes a method on the remote ref to pass across the method request to the server side, RRL. From this RRL, the method call gets passed to the skeleton. The skeleton then invokes that particular method on the appropriate remote object. The method gets executed therefore at the server. The result of the method is passed back to the skeleton. The skeleton again passes back to the RRL here to the other side, to the client side back again, and the result is given to the stub. The stub produces the result to the client. Now, we need to still look at what other things are happening during this communication. That is, when a client makes a request on a method of the remote object, the method could be taking parameters. Now, those parameters could be of different types. That is, it could be primitive types, it could be object types, and if it is object types, it could be a local object or it could be a remote object again. Now, when a method call is made with the parameters, if it is primitive data types, what the stub does is, it does what is known as marshalling. Marshalling means putting together parameters. Along with that, after putting the parameters together, it has to attach the header details and then push across the method request to the RRL by invoking a method on the remote ref. It invokes a method called invoke on remote ref. Now, if it is a primitive data type, then it just puts together all the values of the primitive data type and sends it across during the marshalling process. If it is an object, the object has been created here at the client side. I cannot just send the object across as it is, because then I am sending an address across. If I send an address from client to server, the same address on the server means totally different. So whenever I have to communicate or pass across an object across JVMs, as we mentioned during the stream class and explicitly during serialization, we need to serialize the object and send it across. So during the marshalling process, if there is an object as a parameter, it marshals, during the marshalling, it serializes the object and sends across the object as a serialized content. Now the object, we said, could be a local object or a remote object. If it is a local object, I have to serialize that local object and send it across. If it is a remote object, just like how I am accessing a remote object which is residing at the server as a representation of a stub, if the object is a remote object that I am passing, then I have to serialize the stub object and send it across. So again, stub is responsible for marshalling the request parameters for the method. If it is primitive data type, it just takes the value. If it is a local object, it serializes that local object. If it's a remote object, then it serializes the stub object and sends it across. When the method call comes to the skeleton is responsible for unmarshalling. That is, to recreate those objects. So it passes the primitive values as values themselves, and any local object that had been serialized and passed across, they will be deserialized, that is, it recreates the object. Any remote object that has been sent across, it deserializes the stub object and you get the stub object on the server side. And the method call is made, therefore, on the remote object. Now let us see what happens when a client makes a call to the remote object. Let us say on the server I have many objects like this. When one client makes a call to a remote object, it opens a socket for that client at the server for that particular remote object and communicates with the client for that remote object using that socket. So if I have another client, for this client again another socket is opened to communicate with that object. Similarly, this client wants to talk to another remote object, another socket is opened to talk to that object. Now what is the protocol that we use to talk to remote objects? Now it was previously called as a JRMP protocol, or otherwise known as a RMI protocol. This is a proprietary protocol. So RMI works with only Java to Java communication. JRMP stands for Java Remote Method Protocol. RMI we already know, Remote Method Invocation Protocol. Now, although we use the RMI protocol or the JRMP protocol to talk to a remote object, when I go through the network layer, it is the TCP/IP protocol that it uses to communicate between two sockets or two machines. The default port on which it listens is 1099. Now, in order for a client to get the stub reference, how does it go fetch the remote object? First of all, in order for a client to invoke a method, I need that object reference. The object is actually residing at the server. So, how does the client get a reference of that object type which is residing at the server? For any remote object, we must define an interface. Interface is a binding between, or it's a contract between the client and the server saying what business methods would be available for a client to call on that particular remote object. So, we write an interface. That interface would be available both at the client and the server. At the server, you will have an implementation of that interface and an object created for that implementation. So, the remote object is residing at the server. The class is not available at the client. If the class would have been available, the implementation class would be available at the client, then it becomes a local object. So, when a client wants to talk to the remote object which is residing at the server, first it needs to get the reference of that remote object. What the server does is, once it creates the remote object, it places that remote object onto what is known as a RMI registry. So, this RMI registry is nothing but a naming space on which the objects are placed. So, I place the reference of O1, O4, O2, O3 onto RMI registry. Now, RMI registry itself is another application. So, it is a different JVM. Now, we got therefore 3 JVMs: client, server and the registry JVM. Onto the registry, these objects are placed with a unique name, which is called as a bind name. The client, when he wants to get the reference of any particular remote object, he needs to know for which remote object what bind name has been used. So, in the client program, you are going to specify the bind name to look up for into the registry. So, client will look up into the registry by giving a bind name, and against that bind name a particular reference would be stored, particular object would be stored. That particular object reference is returned to the client. Now, object O1 has been created at the server. When the server needs to bind the object onto a registry, the server is going to talk to the registry using the bind or the rebind method, which we will discuss little later on that. And when it uses the bind or the rebind method, it specifies the bind name for the object and the object which it wants to bind with. At this point, the registry is a server, server is a client to the registry, and again we are talking about remote method invocation, because we are invoking a method onto the registry to pass across the object with a bind name. So, once we invoke the bind or the rebind method on the naming interface, which is a common interface available to both registry and the server, and that is a remote call. So, therefore, even for a registry we have a stub and skeleton concept. The stub is automatically loaded to us, dynamically loaded rather. Okay. So, we pass the bind name with the object to the registry. That object that you are passing, remember naming.bind or rebind is a remote call, and the object that you are passing to the method is a remote object. So, when a remote object is a parameter to the remote method call, how does it pass across the object? It cannot pass the address, obviously. It passes it as a serialized object. But does it serialize O1 itself? No, it serializes the stub object and sends it to RMI registry, because when I pass O1, it's a remote object, it's not a local object. So, the server, when passing the remote object, it is actually in the RMI call, it actually takes the stub, serialized object of the stub, and sends it to the registry. So, now that gets placed into a registry. Now, once the object has been placed in the registry, now the server becomes a server, the registry becomes a client to this server, to this remote object, because it's the stub which I refer to in the registry. Now, once the object is ready and available in the registry, the client does a lookup on the naming interface. When a client calls a lookup on the naming interface specifying the bind name, it actually goes to this lookup call goes to the stub of the registry. The registry stub passes it to the skeleton of registry, the lookup call, which then looks up into the registry for the bind name and returns that stub object as a return value of the lookup. Now, when I am returning a value from a remote method, again the serialization and the deserialization has to occur in a reverse way. That is, the skeleton has to serialize object if it is an object. If it is a primitive data type which is a return value, it just sends it back as it is. If the return value is an object, and if it is a local object, it will just serialize the object and send it back to the client stub. But if the return value is a remote object, then it serializes the stub object and sends it out. So, in this case, the lookup method which we are calling on the registry stub is passed to the skeleton of the registry. The skeleton of the registry passes it to the appropriate remote object on the registry to invoke the lookup for the bind name. Once it finds the object, it returns that object back to the client. So, that return value comes to the skeleton. Skeleton marshals the return value, that is, it puts together the return value with the header details. During marshalling, if it is an object, it serializes the object and sends it back. If it is a primitive data type, it is just sending it back the primitive data type, the value. So, since the return value here is a stub object which the registry holds, remember that is the stub object which the server has registered with the registry when it has passed the remote object to the registry bind method. So, it passes the serialized stub object to the stub registry, which then returns the object to the client when he has called a lookup call. So, now the client gets the stub object. A stub object is nothing but an interface type of object. Remember, for every remote object you have defined an interface. That interface has been implemented on the stub class. So, a stub is nothing but an interface type. So, once you get back an object through the lookup method at the client side, the client can store that reference either into a stub type of object variable or into an interface type of object variable. Now, I therefore have a remote object reference. Now, once I have that remote object reference, which means I got my stub, then I invoke a method on the remote object. When I invoke a method on the remote object, that gets passed to the stub of the remote object now. Remember, the stub of the remote object is implementing the interface. So when you invoke that method is available in the stub class also, but it does not have the business logic that you have written. That's actually in the implementation class available at the server. So this is just a network implementation of that particular remote method here to pass across the information to the other end. So this is how a method invocation and fetching of the remote object occurs in RMI, and this is the architecture of RMI. So now with this, let us look at how to write a RMI application. Now let us look at how to write an RMI application. In order to write an RMI application, first thing that we have mentioned is we need to write an interface. We said in this interface, it's a contract between server and client, which basically declares all the business methods which a client can invoke. So this interface declares all business methods that can be invoked by the client. If this interface type of object has to be a remote object, then we need to extend this interface with remote interface. So to work with RMI, we need to import java.rmi.star and java.rmi.server.star. This remote interface is available in the RMI package. Another thing is, during the method calls, there could be some network problems, due to which you can end up getting remote exception. So all methods must use throws remote exception. So this is what gets into an interface. The next step is to write the implementation class. That is the class which is going to implement the interface that you have written. So implement the above interface implement the methods of the interface extend from unicast remote object class. Now you have this unicast remote object class in java.rmi.server package. This class helps in exporting objects. when you need to pass the object from server to remote to the registry and from registry to the client, it helps in exporting the remote object, the unicast remote object class. And it also identifies the type of server, that is, it is a unicast type of server, which means I cannot replicate the objects. So, suppose you are unable to extend your implementation class with the unicast remote object class, that is, if not possible to extend from unicast remote object class, then from within the constructor of your class, invoke the method export object, which is a static method, unicast remote object dot export object of this. So, if you are unable to extend your class with unicast remote object class because it has to extend from some other class, in case of applets, for example, if you are writing an applet program, you have to extend your applet class with a applet. So, in that case you will not be able to extend with unicast remote object. So, provide a constructor, from within the constructor you invoke the method called unicast remote object dot export object of this. This particular method as well as the constructor of unicast remote object throws remote exception. So, your constructor should also use throws remote exception. So, this is how you implement the implementation class. The next step is to write the program which is going to create an instance of this class. So, let us call that as a server program. Write a server program. The server program will create an instance of the implementation class. When I create an instance of the implementation class, since it is implementing an interface and the interface is nothing but extending remote, so therefore an object of the implementation class is also a remote object. So, what you have created here is a remote object. Now, you need to place this remote object onto the registry. To place a remote object onto a registry, you invoke naming dot bind, which takes as a string the URL where the object has to be bound and the object itself with the bind name. That is, you specify the bind name, comma, the remote object, or you can use naming dot rebind of the same two parameters. Now, the question is, what is the difference between bind and rebind? When you use the bind method to place an object with the bind name, you cannot later replace this bind name with another remote object. If you try to do so, you get already bound exception. So, once you place with the bind name a remote object using bind, that is it. No changes can be done. to that particular bind name. But if instead of using bind, if you were to use rebind, specifying the bind name and a remote object, later in time if you want, you can change the remote object specified for this bind name with another remote object. So it's a replacement. If you have a doubt, can I say bind and then call rebind on it later? No, you cannot. They are independent of each other. Either you call bind or you call rebind. Now, this basically means that where is it that I am going to place the bind name with a remote object? I am assuming that here, that wherever the server program is running, wherever I am going to run this particular program, in the same machine with the default port, RMI registry is running, because I am going to place this onto RMI registry. This is a call to the RMI registry. This is a remote method call to the RMI registry. Suppose your RMI registry is in a different machine and your server is running in a different machine, then you must specify the path here. You have to specify as machine name colon port number slash the bind name. Even if the port number is different from 1099, if the registry is not running on 1099, I'll tell you how to change the port number later. Even if the registry is not running in 1099, then also you must specify this. So machine name colon port number slash the bind name. Now this is about your server program. The next thing is write the client program. That is, the client has to look up for the remote object, get the reference of the remote object type, and then invoke the method. So first thing is fetch the remote object. That is done by saying naming dot lookup of specify the machine on which your registry is running. So machine name colon port number if required, if it's not running on a default port, slash the bind name. And the protocol that you need to use is RMI protocol. The lookup will return a remote type of object which you need to downcast to either a stub type or to a interface type. Once you downcast it, then you invoke the method on the remote object. This is the client program. Now the question is, how do I compile all this? What do I run where, and what files do I keep and where do I keep them? So let's look at all these things. To compile these programs, first compile the interface. Then first the interface, then you compile the implementation class, then compile the server program, and then compile the client program. Now where do you get the stub and skeleton? We mentioned stub and skeleton are classes. Where do you get these classes from? To derive at a stub and skeleton class, you make use of the command called RMIC, that is remote method invocation compiler. Now remember one thing, that if these classes are in a package, you must use javac -d path and the file names. So appropriate package directory would be created, under that the class files would be stored. So when you need to generate the stub and skeleton, the stub and skeleton are basically a representation of the remote object. Rather, the stub is a proxy to the remote object. So which is your remote object out of all these class files? It's the implementation class, because that's the one which is the remote object, whose object you are creating, that becomes the remote object. So once you are done compiling the implementation class, at any point you can generate the stub and skeleton using RMIC. Now if this belongs to a package, the interface and the implementation class, then you have to do a RMIC with the -d path also, so that the stub and skeleton classes will also be placed into the package directory. If not, you can just specify RMIC file name. So to generate the stub and skeleton class files, you use the RMIC command with the implementation class file, not the Java file. Remember, that's why we mentioned after compilation of the implementation class file, anytime you can generate the stub and skeleton. So we say RMIC followed by the implementation class. Do not give the extension dot class, just give the implementation class. If this implementation class happens to belong to a package, then you have to say package name dot the class name. Now this RMIC command therefore will use this implementation class file, then it generates two class files. Depending on whatever is the name of the implementation class file is, so that particular IMPL name, implementation class file name underscore stub dot class, and implementation class file name underscore skel dot class. These two class file will be generated and placed along with the implementation class file. So now how many class files do you have? There are 4 of these plus 2 of these, 6 class files. Since JDK 1.2, the RMIC command generates only the stub class, not the skeleton class, because the implementation of the skeleton class has been pushed down to the RRL layer. Now once you have all the class files, now you need to know where to place these class files. For the client, you would require an interface in case you are going to downcast the object that you looked up for into an interface type, and if you were to store it into an interface variable, you require an interface class file. If you are downcasting to a stub class file, then all you need is a stub class. Otherwise, we need the interface. You can place the stub class and the client class. The server side, we require the interface, the implementation class, the server program, the stub class, and the skeleton class. Now the question is, we did mention during the architecture of RMI, the stub is being used at the client side, and therefore at the RMI registry also, because we did say when the server is trying to call the bind or the rebind method, at that point the server is the client of RMI and registry is the server of RMI. And once the object has been placed, the registry becomes client to RMI and server becomes a server to RMI again. But for a client, registry is a server, a client is a client program at any point, client socket. Again I repeat, when the server is calling bind or rebind, at that point server is a client socket, registry is a server socket. After binding the object, registry becomes the client socket, server becomes the server socket. The client is always a client socket. For the client, registry is a server socket, but for the server it is a client socket. So, for the server side, why do we have a stub class? Because I can dynamically download the stub. I need not keep the stub class on the client. In that case, I require the stub class to be downloaded. So if I have to download the stub class, I need to have it at the server, right? So therefore, the stub class has to reside at the server. And at any point, if I am going to pass an object of a class, which is a remote object which I have created, as a parameter or a return value, then RMI requires the stub class to serialize. So again I require the stub class at the server. So therefore we need the stub class to be placed at the server. Now once we have the class files in the appropriate place, then you just have to run the program. To run the RMI application, what we need to do first is, first thing that you need to do is set the class path. Set the class path where the stub class can be found. Because when the server calls the bind or rebind passing the remote object, it needs to serialize the stub class object and sends it across. So it needs to know where the stub class is, and for RMI registry also, since it's going to hold the stub object as a reference, it needs to know where the stub class is. Otherwise, while running the server, we get an error, exception, RMI exception. When we set a class path for RMI, it must be an absolute class path, it cannot be a relative class path. So first thing is set the class path where the stub class and all the rest of your classes can be found, and then start the registry first. So in order to start the registry, run the registry, you say start RMI registry. To bring up the RMI registry, you give the command start RMI registry. Now let's say all this is being done at one command prompt that I have opened. Let's call it as command prompt 1. So we set the class path at this command prompt, we set start RMI registry. When we call start RMI registry, it opens a new command prompt window. In that the registry is getting executed with the class path whatever you have set. Now the next step is, the command prompt which you had opened with the class path set is still available for you to use. There you can run your server program, which is going to have your main function in it. So the class path is still available for the server program. When you run the server program, it calls naming.bind to pass the serialized stub object to the registry. Now on which port is the registry listening on? 1099, that's the default port. If at all you want to change the port number on which the registry is going to listen on to, then you can optionally specify the port number here. So which means in your bind or the rebind as well as your lookup calls, you must specify the port number explicitly. If it's listening on a default port, then you need not mention the port number. So once the server program is running, in this command prompt, your server is up, your registry is up. Why did we bring up the registry first? Because when you run the server program is going to call naming.bind or rebind. That is nothing but a method to be called on the registry. So in order for a server program to call a method on a registry, the registry should be up and running. The object should be up and running. So run the registry first and then the server program. Then open to another command prompt. If I am going to run all this in a single machine, I am going to open up another command prompt, set the class path again here to find out where the files are available, the class files are available, and then run the client program. So Java client program. Once the client has gotten the remote object reference, even if you were to suppose shut down the registry, it will still work because I've got the stub reference and on the client, and after that it's just a communication between server and the client, not between registry and client at all. But then once you shut down the registry, now you no longer can access any other objects. You cannot look up for any other objects. So ideally you wouldn't be shutting it down. So this is how you run the RMI application. In this particular situation, if we look at it, the object once you create at the server, it's always up and running. Now maybe certain objects you don't access at all very frequently, but they're still taking up your application resource space because it's always running. In JDK 1.2, they introduced activation model for RMI, in which the objects can be brought up as and when required and then shut down using the RMI daemon processor. So again you have different set of interfaces to work with in case of activation model. You have activation descriptor, you have activation interface, which is a like a remote interface using which you will define your RMI activation model program. We also mentioned that RMI protocol or the JRMP protocol is a proprietary protocol, so therefore it works only between Java to Java program, that is JVM to JVM communication is always done with RMI protocol. What if I have a requirement of communicating between a JVM and a non-JVM, maybe with C or anything else? Of course, we can use the JNI concept and talk to C or C++ or whatever. And what is another method available? They introduced Java IDL, interface definition language, that's the Corba concept, in 1.2 JDK. And later in 1.3, the OMG had introduced the IIOP protocol, so that was incorporated in JDK 1.3, that is RMI IIOP protocol. IIOP stands for Internet Inter-Orb Protocol. So if you want to communicate between JVM and non-JVM using remote method calls, then you use the RMI IIOP protocol. Now coming back to this, we did mention it's not a must for me to keep the stub class at the client side. I can dynamically download the stub class. If I want to dynamically download the stub class, then how do I run my program? How do I know where to download my stub class from? You need to specify a property called java.rmi.server.codebase, specifying the URL where the stub class can be found. And that is done when you are running the server program here. So when running the server program, what you do is say Java minus capital D, do not give any space after capital D, just say java dot RMI dot server dot codebase is equal to the URL followed by the server program. So when you do this, and when the server program calls the bind method to place the remote object onto the registry, this URL will also be written along with the object, along with the serialized object that is being sent to the registry. The codebase value will also be available with the serialized object that we are sending to the registry. So when the client looks up for the remote object onto the registry and there is no stub class, in your class path of your client, it should not be there, otherwise you get an exception. If in your class path it finds a stub class, you get an exception when you have used the codebase property to dynamically download the stub. So if in the class path it does not find a stub class, there is no exception, then whatever the codebase is specified against that bind name in the registry for the object, it goes to that particular specified codebase URL, downloads the, fetches the class file, the stub class file to the client side along with the remote object, that is the stub object. So the client is actually getting, when I say it gets the reference of type remote object, it's the stub object it's getting. This URL that you are specifying can be either FTP protocol, HTTP protocol or file, only one of these three. Similarly, just like how we can dynamically download a stub class, we can dynamically download any class for that matter, let it be from server to a client or client to a server. Because let us take for example, a client is sending an object as parameter, maybe that class is not available at the server side. Then I would want to dynamically download the class to the server side, then while running the client program, we need to mention the codebase property with the URL. So it need not be only for the remote object that we specify the codebase. Codebase can be specified for local classes as well as remote classes. So a server can download classes or refer to classes from the server's class path, from the server's codebase, from the client's codebase as well, if for a client you have specified the codebase. A server cannot refer to client's class path. Similarly, a client cannot refer to server's class path variable. Since we are downloading class files dynamically or for the remote object, the classes are loaded through RMI class loader object, not the plain class loader object. So when the class gets loaded here, the IMPL class, it gets loaded via RMI class loader object. The remote objects garbage collection is a distributed garbage collection. What I mean by this is, since the remote object is residing at the server and the client just gets a reference of type the remote object, the server keeps track of how many clients are referring or currently connected to that remote object. So every time a client connects to a remote object, it increments 1 by its count. Only if the count reaches 0, the remote object residing at the server will be garbage collected at the server. So, for the client, he cannot garbage collect the remote object because it is a remote object for him, it is not local to his machine. So, that is why it is a distributed remote garbage collection. Now, can at any point, let us assume all the clients who are calling upon the business methods, if there are no such clients available, can an object be garbage collected? No, because our RMI registry is also a client to the remote object. So, at least one count will be there unless and until I bring down the RMI registry as well. That is the only time it can reach to 0. Now, once an object has been referred by a client, how long is the socket which has been allocated for that object for that particular client available to talk with? By default, it is available for 10 minutes. You can set this value by specifying a property called java.rmi.dgc.leaseValue is equal to, in terms of milliseconds, you specify a value here. That becomes the lease value time for your objects. Now, what exactly does it do when it reaches the lease value period? So, by default it is 10 minutes. So, once a client has requested on a remote object, as it checks every 10 minutes, the server checks whether that client has made a call since 10 minutes. If he has not made a call, then it cuts the connection between that client and the server object. So, all over again you have to connect back and talk to the remote object. The connection is lost basically. But if suppose the client is still connected, that he has accessed within this 10 minutes to that remote object, then it just refreshes the connection. So, lease value is used to basically check whether a client is still using. If not, disconnect. If so, just refresh the connection. It is like a session timeout. So, these are some of the properties which can be set during execution of your program, RMI program. So, this again have to be set at the server program, at the server side. So, after every property can be specified with capital D, no space, property name is equal to value, space, again capital D, property name value, and finally specify the server program name. This is how you run your RMI application.